is Scacca, and this is problem 1A of video 2B for Calculus Assessment 2. So problem 1A is asking for the derivative of e to the x times arc sine e to the x. And in this problem, we will be using the product rule, the derivative of sine, as well as the chain rule, since it's not just an x in the parentheses right here, it's e to the x. So for product rule, we take the first times the derivative of the second, which would be e to the x times the derivative of arc sine e to the x. So the derivative of arc sine is 1 over the square root of 1 minus x squared, but in this case it would be e to the x squared, since it's not just an x in the arc sine. But then we would have to multiply by the derivative of the inside right here, because it's not just an x, so we have to do the derivative of e to the x, which is just e to the x. So then we do plus the second, which is arc sine e to the x, times the derivative of the first. And that would just be e to the x again. My name is Scacca, and this is problem 1B for video 2B of Calculus Assessment 2. And problem 1B is asking to find the derivative of 7x cubed times arctan of x. So we're dealing with the product rule again, as well as the power rule in the first term. So we do first times the derivative of the second, and the derivative of arctan is just 1 over x squared plus 1. And then we do plus the second times the derivative of the first, which we would take the 3 and pull it out front. So it would be 3 times 7 in parentheses x to the 3 minus 1. And then we could simplify and just rewrite the first portion and make this a 21 x squared. And here's the unsimplified answer. Hi, my name is Scacca, explaining problem 2A and B for video 2B Calculus Assessment 2. So A is asking for the velocity equation from this position time function. And since it's asking for velocity, it's asking for the first derivative. So s prime of t is equal to, and this is just a combination of a bunch of power rules put together. So we would pull the 3 out in front, multiply it by 1 since there is no constant here. T3 minus 1, because we drop this value by 1, minus 2 times 24. Remember, we bring this 2 out in front. So 2 times 24, t to the 2 minus 1, and then plus 1 times 144, t to the 1 minus 1. So we can simplify this. We get s prime of t is equal to 3t, 3 minus 1 is 2, minus 2 times 24, which is 48, t to the 1, because it's just 2 minus 1, plus 1 times 144 is 144, and then t to the 1 minus 1 is 0, which drops this t, so we no longer have a t at the end. So for problem B, it's asking for when the object stops moving, and it stops moving when the velocity, or in this case, s prime of t, is equal to 0. So we could just set this top equation equal to 0, and we get 0 equals 3t squared minus 48t plus 144. So what can we do? We can pull out a 3 to the front, and we're left with t squared minus 40, oh no, my bad, minus 16t plus 48 equals 0. And then we can think of two constants that multiply to 48 and add to negative 16. So that would be negative 4 and negative 12. Set it equal to 0. Now we can set each one of these equal to 0. So 3 equals 0, and that's not true. T minus 4 equals 0, and t minus 12 equals 0. Add 12 to both sides. Add 4 to both sides. So we're left with t equals 12 and 4. So this means that the object that it's talking about stops moving at 4 seconds and 12 seconds. Hi, my name is Scacca, and I will be explaining problem 2C, video 2B for Calculus Assessment 2. So part C is asking, when is the object moving forward? And we can tell when the object is moving forward when the velocity is greater than 0, or when s prime of t is positive. So we can take our velocity equation, which we already got in part A, and we can make a number line because we already know when the particle is stopping, right? So make a number line from 0 to whatever number. In this case, I'll use 17. And we know that the particle stops at t equals 4 and t equals 12. So we have to find numbers between each of these intervals to see when is the velocity positive. So between 0 and 4, I picked 2, 4 and 12, 8, and then 12 and 17, I picked 14. Okay, so now we plug each of these into the velocity equation to see whether or not they're positive. So s prime of 2 is equal to 3, and then we plug in a 2 squared minus 48 times 2 plus 144. We can simplify. This becomes 3 times 4 minus 48 times 2 plus 144. Simplify even further. 12 minus 96 plus 144. And then we get the answer to be 60. Now we know that that is positive, so right here it is moving in the positive direction. And now we can try the same thing for 8. Let me grab another page. S prime of 8, plug it into our equation. 3 times 8 squared minus 48 times 8 plus 144. Okay, simplify. This becomes 3 times 64 minus 48 times 8 plus 144. Simplify even further. 192 minus 384 plus 144. That gives you a final answer of negative 48. So it's negative, so it's moving backwards in the negative direction. Here, let me switch colors so you can see. This is positive, this is negative. And then we plug in 14 now. S prime 14 equals, plug in 14. This becomes 3 times 196 minus 48 times 14 plus 144. 588 minus 672 plus 144. That gives you a final answer of 60, which is also positive. So we can go back to our number line. And it is positive here. So now we can say the bead is moving forward at the intervals 0 to 4 seconds. And 12 to 17 seconds. Hi, my name is Scacca, and I'm explaining problem 2E and F for video 2B Calculus Assessment 2. So E and F sound like they're asking the same question, but we can see total distance and net distance are completely different. So to find the total distance, we have to add up all the motions of the bead into one, and then we get the total distance. The net distance takes into consideration is the particle moving forward or backwards, and if it's moving backwards, we subtract from the total amount. So we know where the particle is stopped, so we can use this for our position time function. And we know that it stops at the points 4, 12, and it wants us to end at 17. So we can plug each of these into the equation, and we can start with S of 4. And plug it in. And for 4, if we plug everything into our calculator, we get 256. S of 12, plug in the 12. And then we plug it into our calculator and we get 0 actually. And then S of 17, plug 17 in. And then for this one, we get 425. So now we know the positions at each of the stopping points, which means that this is a max, this is a min, and then this is a max again. So we know the particle moves from 0 to 256. And then it goes from 256 back to 0. So we would actually add another 256 because it moves a total of 256 in the negative direction to get back to 0. And then we add 425 because it's moving again in the positive direction. And then we can plug that into our calculator. And you get 937. So the total distance traveled by the bead is 937. And we can go back and input this information over here. So total distance, hold on, let me see it again, 937 centimeters. And then F is asking, what is the net distance? So we can see that the particle is moving forward from 0 to 4 seconds. And if it's moving forward from 0 to 4 seconds, let me just erase this. The particle is moving forward from 0 to 4 seconds. It moves in the positive direction 256 centimeters. And then we know that it's moving in the negative direction to get back to this 0. So we subtract 256 because it goes in the negative direction. And then the final, it goes forward another 425. Then we add, and our answer is just 425. So the net distance is 425 centimeters, excuse me. Hi, my name is Scacca, and I'll be explaining problem 2G, H, and I for video 2B, Calculus Assessment 2. So G is asking for the acceleration function for the bead. So we already took the first derivative, and acceleration we know is the second derivative. So we take our velocity equation and we just take the derivative of that again. So we get s prime prime of t equals, bring the 2 down to the front, multiply it by the 3 to the x, multiplied by x, t, and then 2 minus 1. Minus, bring the 1 down, 1 times 48, t to the 1 minus 1, and 144 just gets dropped off because there is no variable here. So when there is no variable, it's basically just cancels this constant out. So plus 0. Then we can simplify to 6t. 2 minus 1 is just 1, so we could just leave that as is. Minus 48, and the t drops off because 1 minus 1 is 0, and t to the 0 is just 1. So this is our acceleration equation. And if we go back, H asks us to graph all three functions, and I is figuring out when it is speeding up and slowing down. So I already graphed them in Desmos. You can see on the x-axis we have time in seconds, and the y-axis is distance in centimeters. So the red graph is showing the position time, the blue graph is showing velocity, and the green graph is showing acceleration. So by looking at this graph, we can figure out if the particle is speeding up or slowing down based on the acceleration. If the acceleration is negative, that means that the particle is slowing down. If the acceleration is positive, that means that it's speeding up. So we can see from 0 to 8 seconds, the green graph or the acceleration graph is in the negative. So that means that the bead is slowing down from 0 to 8 seconds and speeding up from 8 onwards, so 8 to infinity, or in this case 17. So we can go back. The graph is speeding up when the acceleration is positive, so from 8 to infinity, or 8 to 17, based on the previous questions, and it is slowing down when the velocity is negative, so from 0 to 8 seconds.